All right, we are solving equations with rational exponents. This is a fun topic today. All right, so our first goal is to isolate the variable and the rational exponent. All right, so goal number 1, isolate the variable and the rational exponent. Step 2, raise both sides to the reciprocal power. So for example, if my power was 2/3, the reciprocal would be 3/2. I'm just flipping the fraction. Now this is really important. If you're taking an even root, it will have 2 solutions. If you're taking an odd root, it will have 1 solution. So this is new to us, talking about the number of solutions. And most important, and I can't stress this enough, the most important thing is to check. And when we say check, we're just using the store feature. All right, so we're going to walk through 8 different examples. We'll take our time on each one. Each one will be slightly different. So example 1, I want to isolate the variable and rational exponent. So this 2/3 is only sitting on the x. And here's what I want you to do. I want you to box that in. I have to isolate that. I have to get that by itself. So just use some common sense. Who would you move over first? Hopefully you said you would add the 7. It's just solving simple equations. 2x to the 2/3 is equal to 18. Remember that 2/3 is only with the x. Who would you move over next? All right, the 2. So I'm going to divide the 2 out. X to the 2/3 is equal to 9. So we are close. Okay, so we isolated the variable and the rational exponent. We're going to raise both sides to the reciprocal power. So I'm going to wrap each side up and say to the 3/2 to the 3/2. So our step 2. Why are we doing this, you might be asking? Well, here I'm going to get 6 over 6, which is 1. So I'm going to get just x here. And that's exactly why we're doing it. This is how you get x by itself. You raise both sides to the reciprocal. Now, here's the tricky part. This is going to be an even root, right? The roots go on the bottom. So I am taking the square root of 9 cubed. Here's the problem. When you take a square root, you are going to get 2 solutions. Think about this. What 2 numbers multiplied in 9? You might be thinking 3, which you are correct, but there's another number that multiplies to 9, another pair. X could also equal -3. 3 times 3 is 9. -3 times -3 is 9. You're going to get 2 different answers here, and most likely one of them is extraneous. So now I raise those to the 3rd, so I'm going to get either a positive 27 or -3 to the 3rd is a -27. Okay, so this is why we have to check. We have to determine if something is extraneous or if they are both solutions. So and this just takes time, right? There's nothing we can do about it. Let's start with positive 27. We're going to take that 27, store it into x, and we're going to type in our equation. 2x raised to the 2/3 minus, oopsie, gotta come down, minus 7. I get 11. That checks. I like 27. Now we've got to test -27, store into x. Now once I've got it typed in, I'm just going to arrow up and grab that. I get 11. Nothing is extraneous. So in this case, I'm going to identify both answers. I have 27 and -27. Okay, so this is going to happen when we have an even root. We can get 2 solutions. All right, let's try another one, number 2. So let's go back and talk about our goal. We want to get the variable and the rational exponent by themselves. So my goal is to kind of get this term by itself. So who would I move over first? Hopefully you're saying subtract the 10. So that would be -64 equals m minus 10 to the 3 halves. This is not by itself yet. I have to first divide out the negative. So 64 equals m minus 10 to the 3 halves. Now I went as far as I can here, and I'm going to go to step 2. Raise both sides to the reciprocal. So the reciprocal of 3 over 2 is going to be 2 over 3. Those undo each other. Here I just get m minus 10. And here I'm going to take the cubed root of 64 squared. Now here's the good news. This is an odd root, so I'm only going to get one answer. The cubed root of 64 is just 4. So I get 4 squared equals m minus 10. 16 equals m minus 10. I'm getting m equals 26. Now, just because I got that answer doesn't mean it works. I've got to check to see if it's extraneous. So I'm going to take that 26, store it into x. And I know this side's negative 54. I'm going to type this side in. 10 minus, parenthesis, x minus 10 raised to the 3 halves. I get negative 54, so 26 is a keeper. All right, I actually kind of enjoy doing these. It's kind of just solving a simple equation. But let's keep trying. Let's see how different they can get here. All right, number 3. So again, this 5/3 is only on this piece. So my goal is to get this by itself, isolate that term. So PEMDAS order of operations, hopefully you're thinking move over the 6 first. So that's going to get me negative 5120. It's negative 5 times 3x plus 22 to the 5/3. Okay, I'm going to box it in again. This 5/3 is only on this term. So my next move would be to divide out the 5. So it's going to get me 3x plus 22 to the 5/3. I don't know this one off the top of my head. 5120 divided by 5. And 24. The two negatives make a positive. All right, now that I've got that variable, kind of base and exponent by itself, I'm going to raise both sides to the 3/5. And again, the whole point is those undo each other. They made a 1, so I'm left with 3x plus 22. So I am taking the 5th root of 1024 to the 3rd. Now, maybe the 5th root of 1024 isn't one you know off the top of your head. Can't say that I do for sure. I can have a good guess at it. But if I hit math, you notice there's a cubed root? This x means you can take any root your heart desires. So if I choose that, I can type in the 5th root of 1024. And it turns out to be 4. So then I have 4 cubed equals 3x plus 22. I know 4 cubed is 64 equals 3x plus 22. I'm just going to do my math on my screen here. I'm going to take that 64, I'm going to subtract the 22, and then divide by 3. So I get x equals 14. And before I commit to that, I better make sure it's not extraneous. I'm going to take that 14 and substitute it in. And it checks out. All right, let's take a look at 4. And again, remember, if you're doing this at home because you missed class or you just need review, pause it when you need to, try it on your own, and rewind if necessary. All right, so hopefully your gut's saying, well, again, I want to get this base and exponent by themselves. The first thing I would do is add over this 5. So if x to the 4/5 over 2 is equal to 8. Now we've seen enough of this year to kind of get the idea that we like fractions. If we put this over 1, we can simply just cross multiply. So I have 16 equals x to the 4/5. All right, I've got that x and rational exponent by themselves, so I'm going to raise both sides to the reciprocal. Those undo each other. So now we got to be careful. Look at what kind of type of root we're going to get. The 4th root of 16 to the 5th. Now 4 is even, so now I'm going to get those 2 answers. What 4 times can make 16? 2 times 2 times 2 times 2, or negative 2 times negative 2 times negative 2 times negative 2. So I need 2 to the 5th and negative 2 to the 5th. 2 to the 5th would be 32. Negative 2 to the 5th would be negative 32. So again, I've got to check both to see if one is extraneous or they're both keepers. So if I put 32 in, let's see, I've got x to the 4/5 over 2 minus 5. I've got 3. And then I'm going to substitute negative 32 in. I also get 3. So in this case, we're going to keep both again. 32 and negative 32. And again, I'm getting the 2 answers here and not here when the root is even. That is the difference. Even roots will have 2 solutions. All right, let's see what else we can do to make these look a little different. All right, so the self-talk. This 3/2 is sitting on just the x, not on negative x. If I wanted negative x, there would have had to have been parentheses, and there's not. So it is just on the x. So move number 1, I'm going to divide out that negative. So I'm going to get x to the 3/2 equals a positive 27. Okay. Now I've got my variable and my rationals by itself, so exponent by itself, so I'm going to do the reciprocal. Whoops, that's not the reciprocal. 2/3. 2/3. Let's cancel. And this is the cubed root of 27 squared. So again, the cubed root of 27 is 3. 3 squared is 9. And we're back to the checking phase. 9 store into x. Negative x raised to the 3/2. Negative 27. Look at that. Beautiful. All right. Keep on making them ugly here. Try to get us. All right. I've got to get this rational exponent by itself. So again, I'm going to box it in. This is my goal, is to get this piece by itself. So who is your gut telling you to move over first? I am going to subtract the 2. So I'm going to get a negative 648 equals negative 3 times 65 minus n to the 3/2. And again, I'm going to box that in. It is only on this term. So I also have to get rid of the negative 3. So 65 minus n to the 3/2. Let's see, 648 divided by the 3. The 2 negatives cancel. I get a 216. All right, so I'm going to raise it to the reciprocal. I'm going 2/3 to the 2/3. So I am taking the cubed root of 216 squared is equal to 65 minus n. Okay, cubed root of 216 is a perfect cube. If you don't remember it, we can test it out there. Cubed root of 216 is 6. So I get 6 squared. So I've got 36 equals 65 minus n. Now I could subtract the 65. Oops, 36 minus 65. I've got negative 29. And just be careful, you're not left with n. You're actually left with negative n. Therefore, when I divide out the n's, I'm getting the negatives, I'm getting n equals 29. And again, I'm going to do a quick check to make sure that's right. X to the 3/2 plus 2, negative 646. Beautiful. All right, we're cruising, guys. You're doing great. Let's try the last 2 here. Again, I'm going to box in that 2/3 is only on the x. So move number 1, I'm going to subtract my 16. So I have 3x to the 2/3 is equal to, is that going to give me 48? Okay. X, 2/3 is only on the x, so I'm going to divide by 3. So x to the 2/3 is equal to 16. Okay, I'm going to raise both sides to the reciprocal. So 3/2 and 3/2. Uh-oh, what type of root are we getting? I'm going to get the square root of 16 cubed. Whoops, I branched off too early. The square root of 16 cubed. So I'm going to say the square root of 16, that's even, so it can either be +4 or -4. And then when I cube those, I'm either going to get 64 and -64. So again, we're going to check. 64 stored into x. 3x to the 2/3 plus 16, 64. And what are the other one? -64 stored into x. 64. We're going to take them both. So 64 and -64. All right, well, we're killing it. We're moving to the last problem. Doing great. Again, my goal is to get this exponent base by itself. So first thing I'm going to do is subtract 10. So 4b to the -3/4 equals, so if you don't know that, 21/2 minus 10 should get us a 1/2. Okay, now, again, I want to get this by itself. Now, obviously, you can type all this in your calculator. I can just take the 1/2 and divide by 4 and hit math fraction. What have we been doing in class, though? Remember, if I divide by 4, I have that complex fraction, so I'm going to multiply by 1/4. So I'm going to get b to the -3/4 is equal to 1/8. Okay, so again, I'm going to raise both sides to the reciprocal. So I'm going to raise, now I have a negative exponent, haven't seen that yet, but I'm going to raise to the -4/3 and the -4/3. All right, so this is our first time seeing a negative exponent when we've done these. Now I want you to think about this because you know this. What do negative exponents do to this term? The first thing it does is flips it. So I have 8 to the 4/3. Instead of 1/8 to the -4/3, I really have 8 to the 4/3, which is then the cubed root of 8 to the 4th. Cubed root of 8 is 2. 2 to the 4th is 16. And let's go ahead and do one final check. 16 stored into x. 4x to the -3/4 plus 10 gets me 10.5 or 21/2. And we got it. So I think this is kind of a fun little topic. Again, like I said, we're trying to get that base and exponent. I know I said variable and rational exponent. Now that I'm coming back here, it might be better to say base and rational exponent by themselves. And then raise to the reciprocal, and just be careful of those two solutions. We're going to tackle all of these on a separate sheet of paper, and good luck.